Team, it's Mr. Z, and today we're going to continue multiplying fractions. Last time we worked on rewriting fractions. We basically took two fractions and made them one, and then we reduced. Now I'm going to kind of show you, hey, you can kind of do a mix of both in order to make your math more manageable. Let's go ahead and jump on in. All right, so notice how we multiplied, then we divided. Now sometimes it's easier to understand that the smaller numbers are easy to divide. When I have a whole number, such as 1 divided by 1 is going to have a quotient of 1. 2 divided by 2 is going to have a quotient of 1. 3 divided by 3 is going to have a quotient of 1. Negative 1 divided by negative 1 is going to be 1. You get my drift? This works for a whole host of numbers that if I divide them by the same part, they will equal 1. That's because x divided by x is 1. It's kind of considered they cancel, but it's important to remember that this cancel means multiply a 1. It's a sideways 1 where you kind of multiply 1, but it's going to be omitted, and I'm going to show you why. 3 times 1 is just 3. 2 times 1 is just 2. When you multiply by 1, it doesn't change the math. So when I do number 5, I want you to watch what happens. I'm going to rewrite it as one fraction, but I'm going to have restraint and not multiply right away. I'm not going to do it. Now, I'm going to go ahead and rethink about this as 2 times 3 over 3 times 5. I rewrite it in order just to help see things. Now, I go ahead and understand that 3 divided by 3 is going to be 1. So I cross them out. What is left is going to be 2 over 5, the answer. If I did it and multiplied it out, this would be it simplified. A key indicator is that both 2 and 5 are prime. Now, there's an invisible step that happens, and as long as you understand it, you're good to proceed. You turn the above from 2 times 3 over 3 times 5, but you turn it to the problem 2/5 times 1. Where did this 1 came from? This 1 came from 3 over 3, which is the same as 1. That's what you turned it into. And then mentally you can kind of disregard that. Let's try it again for number 7. So I look at it. I'm going to rewrite it as a single fraction. This is going to be 1 times 6, 7 times 12. I took the care to rewrite it in order from going least to greatest. Now, I'm going to go ahead and try to break some of these numbers down. I'm going to go ahead and re-represent the 6. And I'm going to think, what multiplies to be 6? Some factors of 6 are 1 and 6, so the numbers have to be between them. 2, 3, 4, and 5. Well, 2 works. 2 times 3 is 6. So I'm going to rewrite this as 1 times 2 times 3. This is okay. Now, I'm going to rewrite the 12 as, well, let me think about the factors of 12. What numbers multiply to be 12? They have to be between 2 and 11. Well, what is 2? 2 times 6 is 12. I can use this fact. I could go ahead and write 2 times 6. So this 12 becomes 2 times 6. It's really important that I don't make a fact up. If I make a math error here, this is going to not end well. So now I'm going to go ahead and cancel out. What's left? 1 times 3 times 7 times 6. Some of you might be saying, well, I can disregard the 1 because 1 times 3 is just 3, turning it into 6 times 7. Well, if I break 3 down, or not the 3, the 6 down, I'm going to break 6 as 1 and 6. So the factors have to be between 1 and 6, and it's going to be 2 and 3. So I'm going to rewrite this as 3 over 2 times 3 times 7. This is a different way of multiplying, but instead of having to deal with large numbers, I'm left with, well, what? 2 times 7. What's left? There's nothing there. Oh, you have to remember it's multiplied by a 1. Now you can do these problems in more steps or less steps. Right now I'm just trying to display that even if I break pieces off of the piece of bread, it's still going to work out. Some of you, like we're going to demonstrate in number 7, where we break all of the numbers down right away in order to make it as streamlined as possible. So for number 7, immediately right away, I would almost ask myself, hey, what numbers go into 3? Well, 1 times 3, so just 3 really. I'm going to go ahead and break down the 1. Well, that's just 1. So immediately, I've already dealt with both of these. Now I'm going to think about the denominators, 12 and 6, and I'm going to break them down. 12 can be 2 and 6. 6 can be 2 times 3. Now I'm going to go ahead and see if any terms cancel. Let me go ahead and rewrite it. 1 times 3, which is just 3. And then it becomes 2 times 2 times 3 times 6. What cancels out? Well, a 3 and a 3. So all I'm left with is a 1 in the numerator because 3 divided by 3 is 1. In the denominator, now it's a simpler multiplication. I have to do 2 times 2 times 6. 2 times 2 is 4. 4 groups of 6 is going to be 24. So if you're adept at it, you can go ahead and do other tricks to help you out. For example, number 8, I'm going to show you that I'm going to demonstrate. I know that 8 and 4 both share a factor of 4. So I'm going to do in my head 8 divided by 4 and make it 2. I'm going to divide this same thing by 4, making this 1. So I rewrite this as 2 over 9 times 1 over 1, which is just 2 over 9 because 1 divided by 1 is 1. Lots of flexibility here to show off your number sense. The way I showed you before, you can answer any problem like a computer, like a robot. That's the way a robot would do it. Number 5, 6, and 7, I'm trying to show you that understanding the multiplication process has its benefits. And if you can decompose numbers, that's a fancy way of saying break numbers down, it will be more successful because we're trying to keep things no calculator. So hope that was helpful. That's it for now. Goodbye.